Hi, I'm Jim Vandeven.
And I'm Will Durfee. Jim and I are professors in the Department of Mechanical Engineering at the University of Minnesota in Minneapolis. We are the instructors for Fundamentals of Fluid Power. We thank you for enrolling in this course and for your interest in learning more about fluid power. We hope that the course will be an enjoyable experience and that you have as much fun taking it as Jim and I are having teaching it.
The purpose of this first session is to give you an overview of the course, a snapshot of what you will learn, who the course is for, what we expect from you, and how the course is structured. But first, a little about us. I've been a professor at the University of Minnesota for 3 years, and prior to that at Worcester Polytechnic Institute for 4 years. I started my fluid power research as a postdoc in the National Science Foundation-sponsored Center for Compact and Efficient Fluid Power, which is headquartered here at the University of Minnesota. My research is in applying machine design to energy storage and conversion, primarily in the area of fluid power. I'm currently the Education Director for the CCFP, a post formerly held by Will. We've heard from students in industry that there's a real need for education in fluid power area, and thus we created this MOOC. We hope you find this field as fascinating as we do.
I've been a professor at the University of Minnesota for over 20 years, and before that I was in the Boston area where I received my degrees and worked as a professor. I'm a designer and my main research focus is in medical devices. So why am I teaching a course on fluid power? It is because of the research center that Jim mentioned, where we're interested in applications of small-scale fluid power, including wearable fluid power devices for medical applications. Fluid power has tremendous potential for medical devices such as prosthetics and orthotics because of its amazing power to weight and force to weight. I've become a big believer in fluid power, and I hope by the end of this course you will be too.
Now a bit about the course content. You'll be learning fundamentals of fluid power from an engineering perspective. And by fundamentals, we mean fundamentals. By the end, you should have a good understanding of the key components of fluid power, such as cylinders, valves, and pumps, how they can be connected in a circuit to create a system that performs a useful function, and how to use mathematics to describe the behavior of a system. You won't be learning some of the more practical aspects of fluid power, such as the best fitting for a specific application, or how to maintain a fluid power system. That you should be able to pick up on the job.
The content is built around components. For example, we'll start you out with a cylinder, like the one here, from which we will learn some of the core principles of fluid power, such as Pascal's law, and how to calculate volumetric and mechanical efficiency. Conduits are the vehicle for learning about fluid viscosity and pressure drops. From there, you'll be taken to valves, where you'll learn about Bernoulli's equation and orifice flow. Then it's on to pumps, motors, and power supply circuits, using a log splitter as an example application.
You'll be learning how to simulate the performance of simple and complex fluid power circuits using a modern computer simulation package. We're pleased to announce that MathWorks will be providing each of you with a free, limited-term license for SimHydraulics that you can download and run on your home computer. You will be using SimHydraulics throughout the second half of the course. Other topics you will learn include important properties of hydraulic fluids, such as compressibility and inertia, all about accumulators, which are the energy storage component for fluid power, and the servo valve, which is used for precision control. The course closes with a detailed analysis of hydraulic hybrid vehicles, which are an emerging application for fluid power.
Here are some suggestions for you to get the most out of the course. First, watch the video lectures, where Jim and I will present some of the basics. The lecture slides will be posted shortly after the lecture. You can also use the textbook for additional knowledge and to help you with points you might find confusing. In addition, the course has an online discussion forum. This is a great way to get your questions answered by other students. Jim and I and the course teaching assistant will be monitoring the forum and will occasionally jump in with an answer to your question. To get the most of this course, you have to do the homework problems. Each week we'll post a set of problems designed to reinforce the lecture content. Unlike most courses you took in college, the homeworks are ungraded and we post the solutions along with the problems. We do encourage you, however, to make a genuine attempt to do the problem on your own before peeking at the solution. We hope that you will be motivated to earn the Statement of Accomplishment for successfully completing the course. For that, you must receive a passing grade on the course quizzes. The quizzes cover the same material as the homework problems, so if you do well on the homework, you should also do well on the quizzes.
Now, a word about the course prerequisites. Actually, there are no formal prereqs, but we are expecting a certain level of knowledge coming into the course. We have designed the course for advanced undergraduate engineering students, engineering graduate students who are engaged in fluid power research, and members of industry, particularly recent engineering hires who find themselves embedded in a project that involves fluid power. Thus, we expect you to have had an undergraduate physics course. Courses in differential equations, fluid mechanics, and system dynamics would be helpful but are not required.
If you have questions now or later, please feel free to get in touch with us using the contact information on the course site. We're really looking forward to working with you for the next 6 weeks.
One last tip. It is never any fun to take a course alone, so how about finding a colleague at work or a fellow student and convincing them to sign up for the course? That way, the two of you can work together to learn about fluid power.